check this out. Hopefully the camera can pick this up. So one of the consequences of separating the horizontal deflection from the high voltage generation is that you can have high voltage with no raster, no deflection, and you can get burn spots. So I suspect that is what happened here and there, and there's another one up near the top. That high voltage, no deflection, burn the phosphor. So now what? Well, I'm going to start replacing capacitors. And I think I'll save the electrolytics for later because I'll see if they're getting warm. But we don't have horrible hum, and they have to be working to some extent, or the set wouldn't be working at all. So I think my time would be better spent right now on going after the paper caps. I'd like to get an image of some sort sooner than later, because then I can use that as a guide to help me work, troubleshoot the rest of the set. So let's start with the video amp circuitry. So glad I have the SAMs. Alright, let's take a look here. Oh, by the way, power supply is pretty simple, but what's unusual is uses dual 5Y3s in parallel rather than a 5U4. Why? 5U4 has more current carrying capability. I would have thought they could get away with one 5U4 rather than two 5Y3s, but that's what we've got. And then just a simple pi filter with a choke, and double up a couple filter caps after the choke. Very, very simple. Alright, let's see. Video amp. Oh, it has DC restoration as well. So we have a 6AL5 for the detector, and they even give you a test jack. Interesting way to do the contrast. Actually just vary the input level to the video amp. Usually the contrast control changes the bias on the tube to vary the gain of the video amp tube, but here they're just doing like a volume control on the video signal. That's weird. So oh, there's a 1,000 microfarad cap for a cathode bypass. That's kind of crazy. Well, let's change that guy out. That could improve the gain on the video amp, and maybe this guy too. So these electrolytics are not in multi-section cans. They're going to be somewhere underneath. You can tell that because if they were in a multi-section, they would be like a letter, be C4A or C4B. But when it's just a single part designator like that, like C4, it means it's just going to be a single part. So this should be really easy to replace is what I'm getting at. And we can replace that 0.1 that couples the video signal to the CRT. Alright, so I'm going to flip the set on its side. It looks like it's pretty stable to tip it on this side. We've got the high voltage box here to act as a bit of a brace. And, let's see if we can figure out what these parts are. I'm starting to find my way around the chassis. Helps a lot to have the SAM's service info, because it has a photograph of the chassis and a parts locator, one for capacitors, one for resistors. So I was able to quickly find the 1,000 microfarad cap. Had been up here. There's a new one. Very easy to install on the terminal strip right there. And 0.1 microfarad video coupling cap was right down here. 2 peaking coils. They both test good. I also replaced this guy. This is one of the main B plus filtering caps, 30 microfarad, just because it was so easy to get at. I was just sitting right here and popped a new one in. Something puzzled me. When I first looked at this, I was suspicious of this because it looks like it's deteriorated a bit. It's not in the SAMs. it is going from a pin on a rectifier tube, those are the two 5Y3s down there, to the filter cap. And notice it's not shown here, nor is it on a schematic. In fact, in the schematic, they show the power being taken off at pin 8, but this is going to pin 2. Not a big deal, they're generally interchangeable. But what I think it's in between those two rectifiers and C1A. Measures around 50 ohms. I'm going to look in the rider service info and see if it's in there. I can't tell if this is original or if somebody added it. There's something on there. Looks like 97, 26. I don't know. If it's not supposed to be there, I'll remove it. If it is supposed to be there, I'll replace it. But I need to know what I'm supposed to replace it with, because this may very well not be the correct value, and I can't read what's on it anymore. Why would they have added that? A little bit of buffering. You don't want to have a heavy capacitive load right off of rectifier tubes. If you look at the data sheet, they limit the maximum capacity of a direct capacitive input filter. So they might have done it to protect the rectifier tubes. I don't know. If I can't find anything, I'm inclined to put something in there for the same reason, to provide a bit of a soft start. 47 ohms, something like that, like a 5 watt maybe, or a 10 watt. I'm also starting to think that maybe some work has been done. Like, I think this might not be the original cap, although it was riveted in here, but the connection, there was like an extra bit of wire there, like something had been clipped and this was inserted. I'm also seeing some odd stuff here and there. A flexible resistor, that's like from the 30s. That might be original, but this guy I'm a little suspicious of. Mallory resistor looks a little newer than this other stuff. Plus, there's nothing else that looks like this. It was vitreous enamel type power resistor. Versus, say, this one, which I'm pretty sure is original. A very different body style on that. Anyways, let's try powering it up. Well, that really made no difference. The sound might be slightly better. Alright, so we'll keep going. Let's take a closer look at this fine-tuning for a moment. I was wondering why it was so hard to turn. What a weird sort of cobbled together mechanism. There is a spring with some sort of hardened plastic tubing over it that just runs against the shaft. And they also, this is probably soft rubber at some point, now it's rock hard. I think they wrapped that around with the spring just to provide a little bit of tension on it. This knob is not quite on there properly either. Speaking of knobs, this is the early type. Later Westinghouse knobs, they were made out of clear plastic, which are like brass painted on the opposite side, but these are actually metal capped. I picked up a bag of these at the fall early television swap meet, so I'll compare these to the bag I have, and I'll put on better ones if any of the ones I have are in better condition. Meanwhile, I'm gonna maybe put a little bit of grease or something on there and see if I can get this to turn a little bit better. Time for a little update. I did go through my stash of knobs and found a better one for fine tuning. It's not crooked anymore, and a little bit of grease vastly improved the action on that. Did some research. I looked up the rider's service info for this chassis, which unfortunately is a terrible scan and it's really hard to read. But the schematic does not show a power resistor here, but it's also different than the SAMs. I then looked at some other volumes of riders. It turns out that they had quite a few variations of this chassis. They used it for several years, and the design evolved constantly. There's definitely a version where they did pull power off of pin 2 on the 5Y3s, but there's no power resistor. Also, a later revision did switch to a single 5U4. There's also a version with dual 5U4s. The horizontal output stage evolved quite a bit too. Later revision, instead of using dual loctals, switched to a single beam power tube, and they did eventually use a flyback. Now, regarding this design, according to someone who's been working on vintage TVs a lot longer than I have, suspects that they were waiting on getting the patent situation ironed out with RCA about using a flyback design. Apparently RCA had patented a number of early television circuit designs, so this may not have any benefits. It's just they didn't have any choice. Similarly, the Dumont RA102 chassis, like is in my Clifton, also does not have a flyback, and instead uses something somewhat akin to this, although it uses dual 807s. But apparently the reason some of these early makers didn't use a flyback is because they couldn't, for legal reasons. I don't know. Now, as far as the power resistor, I clipped it out. It measures around 50 ohms. I can't tell if it's original or not. I threw in a 40 ohm power resistor because I had one lying around that was a nice high quality power resistor, so we'll go with that. Now, as far as recapping the rest of the set, I'll be honest, there are a ton of caps. I don't want to power this up after replacing every single cap. I'll be here forever. There are a crazy number of 0.1 microfarad bumblebees, for example. So I'm just going to go through and replace all of them right now. I've done 6. I'm thinking there's at least 6 more. We've got 1 here. We've got 2, I think, 2 side by side down there. There's another one. There's another one. It's crazy. Also, they're going to be tough to get at, but I really need to replace those. When I did my initial checkout, I was wondering about those guys. Those are right on the AC interlock. Those are the line filter caps. It's these guys. Those could pop. They're probably paper caps. 0.01 is way too big for a mica cap, so they got to be paper caps inside of a Bakelite enclosure right on the AC line. However, they're going to ground. If it was right across the AC line, I would have already removed them, and the chassis isn't actually connected to neutral or ground or anything, so there's probably not a whole lot of current really going through them, but even so, those need to be replaced with safety caps, so those are going to go. It just stinks because they're right next to a very fragile peaking coil, and I do not want to damage that. But I gotta get those out. And then there are a number of electrolytics scattered around that look like paper caps. That's an electrolytic. That's an electrolytic. I think there might be 1 or 2 others. Got a whole bunch of bumblebees in the horizontal circuit. I expect when I replace these, that will improve. We have 4.1 microfarads. We have a 0.25. A 0.01, another 0.01 up there. Who knows why they have different, well, maybe different voltage ratings. Let's say, who knows why they have different styles on some of these. So some of these are bumblebees, some of these are paper caps, some are this lighter color encapsulated types. Different sources, I suppose. Hey, there's another 0.1. This thing, somebody asked when I posted a photo, what is this? There's a couple bits of coax. That is horizontal and vertical. Oh no, brightness and contrast. Wow, no wonder that's shielded. That's that crazy contrast control I was talking about, where they just take the video signal on one leg, ground the other, and the center leg goes to the video amp. The video amp is there. So there's a signal coming after the detector, going through coax to one side of this, then another coax bringing it all the way back to the video amp. What a stupid design. You have potential to pick up all kinds of noise. You got losses. way easier to just change the bias on the tube to vary the gain. It may not be linear, but geez. Well, at any rate, that's what's inside this, and this is rock hard. That's also going to be an issue, getting at parts behind it, because I can't move it. Maybe if I take that screw out, it'll loosen it up a little, because I've got a couple bumblebees. Alright, so that's the paper caps. I'm going to replace a few more and then try power up. Now, there's also a bunch of mica caps. And I've been seeing more and more advice being handed out that these are so old now, don't trust them, just go ahead and shotgun the mica caps. I'm not crazy about doing that. I'm not comfortable doing that. For one, some of these are fairly large. They could be like 4,700 picofarad. That's a really expensive mica cap. I could use C0G or NP0 type ceramic, which is pretty much as good as mica, but more affordable. But I doubt I have all these values, regardless of the type, and there's a lot of them in here. So I think we're just gonna go with the old the old adage that the mica caps are probably okay, and we'll leave them alone, because man, there's probably 25 of them or so. So let's do everything else first, and then worry about them afterwards. All right, so I'm gonna do a few more of these 0.1s, and then we'll do a power up, and then start doing some of the others. I think I restocked all my yellow axial caps. So I think I'll have enough to do everything. Some of these values are a little less common. Like that's a 3,300 picofarad. This is 1,000 picofarad. I should have something suitable. Now, as far as actually doing the recapping, this is actually quite easy to do. All of these terminal strips, these are eyelets on the end, so you can just heat them up, and most of these there's enough space left in the opening that you can just stick the new component lead. So I just clip out the old part, just leave the stub of it remaining on there in most cases, heat up the solder, stick the new lead through, wrap it around and solder it, and that's it. Goes quite quickly. So like you can see on this guy here, just snip, snip, stick in the new lead, stick in the new lead, move on. Wow, that was a lot of 0.1 caps. I think there's still one or two left in here. I thought I would demonstrate replacing one of these caps. So instead of me just talking about it, you can actually see it happen. So let's get that guy that was talking about it a moment ago. I don't know what the value is because it's just too cruddy looking, so let's clip it out. And I'm going to leave a bunch of length on there so I know where to put the new one. Hey, it's another 0.1 microfarad. It's 400 volts, same as all these, but I suspect this is an old repair, and I am finding old repairs here and there. I'm pretty sure this resistor is a replacement, and it's not quite the right value. It's 7K, it should be 7.5, so I went ahead and replaced that. Alrighty, so another 0.1. I'm using 630 volt caps because that's just all I stock, and I'm going to go from there to there. Now that's just ground, so if I was to use the chiclet style cap, there is a ground right next to it, so I could just go between these two. Chiclet style. That is a chiclet style cap. Alright, let's see. Make sure I get this in frame. We're going to be working down here. Alright. So, let's see. I'll clip off some of this. I could clean off the lug, but honestly... oh wait, no, that's not where it's going. Jeez, that's from a previous cap. That's from where the 33 used to go. I need to go up here. And actually, that lug isn't even all filled up with solder, so I can just put it right through the eyelet and wrap it around. I was saying this goes pretty quick, and the other end goes over here. And that eyelet is also not all filled up with solder, so I can just put it right through the hole and wrap it around. I'll clip off the remains of this first. There we go through and we go around, and now I just need to solder those up, and that's it. Some of them parts are a little harder to get at, but for the most part, this is how it's been going. Alright. And up here, I have not really been checking the resistors. I've spot checked a few. They were close enough. They were within 10-20%. It's like there's an awful lot of caps. There's an awful lot of resistors too. Oops. That solder had not quite fully set up. I touched the blob. Alright, I'll just reflow that. Clear off a little excess here as well. Alright. So in this case, this is actually ground. Yeah, that's grounded. So I could have gone from here over to this lug or over to that lug. But I figure I might as well keep things as they originally were wired as much as possible to make troubleshooting easier should I need to. Alright, so let's fire this up. I expect something to have changed, especially because I almost completely recapped the whole horizontal area. Here we go. The set is on its side because I'm not going to keep turning it over every time I want to power this set up. It's just going to stay here while I work on it. Well, it doesn't look a whole lot different, does it? Sure, it seems like the tuner needs to be cleaned. It's not so easy to get at. Boy, I was really hoping for something more than that. With control works. Well, I think it is time to change tactics. I was being overly optimistic. Well, when I swapped in a few tubes, we saw some improvement. I thought replacing some caps would lead to some positive results, and perhaps if I kept going, replaced all the caps, the set would start coming back to life. However, I'm starting to get a little bit concerned that there might be something else going on here. Maybe that's why the set was retired. So we're going to do some signal injection. I'm going to use that guy back there, the B&K 1077B. I think I can plug it in from where it sits, clear some of this stuff out of the way, and run a cable to it. So we are going to do just like you would do with a radio or an amplifier, and we're going to start at the end and work our way back. I mean, after all, they even put a test jack on here. There we go. So we are going to inject a composite video signal right on that one leg of the contrast control that goes into the video amp, and that directly drives the CRT. So if that works, then we're going to start working our way back and go to this side of the video detector, and then go through the input of the third stage, the input of the second stage, the input of the first stage. This does use a 21 or 22 megahertz IF strip, which the 1077B can support. Okay, the B&K 1077B has been fired up. Now, I forgot that it has goofy test jacks for everything, except the RF output. That has a BNC jack. So rather than going to composite video, because I don't have a good connector for that right now, I am going to use the RF, and let's try to inject some IF. So I am at the input to the detector with my test signal, and the set is fired up. So I'm going to play around with the controls because the IF is actually variable. So I'm going to put the camera on a tripod and fool around with the controls and see if I can actually get anything to come through. I guess it is right here. Ooh, there we go. Aha. Nice. Let's see, can we focus? Yes, we can. So I got to have the horizontal hold extremely counterclockwise, and it's just barely locking. Vertical lock is pretty darn solid, though. That's actually a really sharp image. Okay, now I work my way back. So that is the grid of the third stage. Let's go to the grid of the second stage. So conveniently, it's just pin 1 on every tube. Let's this guy. And yeah, no, got too much signal, so back off my loop. Back off too much. Just cranked up. Okay. Immortalize this with a photograph. And now we go back to yet another stage. This will be essentially now where the tuner goes. And still over there. So, why the heck isn't my signal going through? That means we're talking about a problem in the tuner. That's not cool. Well, I can try a few things. One, I can try a different channel. That's an easy thing to try. And I can try swapping out the tubes in the tuner again. Well, it's definitely good to see something on the screen though. So we know the set is actually working. It's just something between the antenna inputs and the output of the tuner that's not right. Haha! I switched to my Sencor VG91 because it's a little more flexible when it comes to doing stuff with RF channels. And I have the RF clipped right into the input of the tuner rather than the screw terminals in the back. And I tried different channels. I'm on channel 6 right now, and I kept rotating this channel clunker around, and I finally got something. I think the tuner is either filthy inside or something up with the switch contacts, because I had a heck of a time even getting this, and I think if I touch it, I'm likely to lose it again. But that's great. It's great. So the tuner is working. We just have some really dirty contacts. So now I want to go back to recapping, and I want to work more on the horizontal because I can't get the horizontal to lock very well. It's just with the horizontal holds, go fully counterclockwise and still just not quite there. So I assume some part is leaky or drifted off value. So let's see, I got channel 5, so I should. Yeah, for some reason channel 6 is, let's try channel 7. No. It's just 6 so far is the only one I've been able to pick up, and even that's very difficult to do. The tuner, I still haven't figured out. I don't know how to open it up to clean it. I might have to disconnect it and unmount the whole thing to get in there to clean it. There are some holes in it. I don't want to just flood it with contact cleaner. I want to take a look inside and see what's going on. But hey, fantastic. Fantastic. Now we can proceed.